So to find the rate that something is growing or decaying, you want to remember the fact that your R value is helping you find your B value. So we haven't stopped talking about B. B is still the MVP. B is still that growth or decay factor that we've always talked about, but we've thought about it in the terms of it being 1 plus R or 1 minus R. So now the question is, well, what if I'm just given B? What if I just have B? How do I know how much I'm growing or how much I'm decaying? So at first it's going to seem really, really easy. So look at this example, but don't get overconfident here because it seems really easy when it's growth. But then when we get into decay, there's some really classic mistakes that are made. So if you look at this first example here, we've got the fact that a function grows by the equation y equals, so if we highlight this guy here, y equals 295 times 1.35 raised to the t. Does that represent growth or decay? So the first thing is to note, well, is it growth or decay? It's definitely growth because 1.5 is, 1.35 is greater than, I wrote less than, 1.35 is greater than 1. So that is definitely growth. We are growing, but at what rate? So the way we determine the rate that we are growing is we ask ourselves, well, growth, if you go back to our formula, is 1 plus R, right? 1 plus R. So, well, what is our 1 plus R? In this case, our rate of growth is 1.35. So we simply take the growth factor, which is 1 plus R, and we set it equal to our B value. Again, so remember, this 1 plus R is our B value. So we have to remember that 1 plus R and B are the same thing. So now we have actually a very basic equation to solve. If we're trying to solve for R, all we would need to do here is subtract this 1 over. Remember that it's 1.00. Subtract that 1 over. It cancels out over here. R equals 0.35, which if we convert that to a percentage, that's 35%. So the rate of growth in this particular equation is 35%. So again, what we did was we set the 1 plus R, we determined it was growth. We set it equal to the 1.35, so 1 plus R equals 1.35, and then we just solve for R. It's the same process, but a little tricky because in this example is really easy. You could actually probably just tell right off the bat that when you look at 1.35, you're like, well, yeah, that 0.35 is my 35%. Let me show you why that's dangerous when we think about decay. Because now a lot of people are just going to look at 0.72 and they're like, oh, then it's decaying 72%. No, right? No, 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 no. That is not decaying 72%. Because you have to remember that 72, that 0.72 is not your R. So remember, we're going to say, hey, that is less than 1. And so because we are less than 1, this is going to be exponential decay. So if it is decay, we're going to set this equal to 1 minus R. 1 minus R, and that equals the 0.72. So here's where it gets a little tricky for people, is we have a little more trouble with this because of the fact that it's going to be a negative number. If we subtract this 1 over, it's going to give you a negative number. And that's okay. We should be fine with it because it's negative R equals, in this case, when we subtract that over, we're left with negative 0.28. So if it's negative R equals 0.28, then divide by negative 1 if that's what you'd like to do. And we're left with positive R equals positive 0.28. So now we have solved for R. And we recognize finally again that what we are decaying by was not the 72%, but what we were decaying by was 28%. That's my rate of decay. So that is a little bit more challenging, but it's important that we follow that process. So hopefully you're starting to kind of follow what we're doing. Good luck on your practice problems.